Welcome to lesson 0.1. We're going to talk about slopes of lines. Let's go ahead and pray. Father in heaven, in Jesus' name, we thank you so much for another day. I thank you for my student, and I pray now as we get into slopes of lines that you would help me to explain this in a way that's understandable. Give you praise for all things. In Jesus' name, amen. Okay, we want to be able to know how to find the slope of a line from ordered pairs. We want to be able to graph right triangles using the slope. We want to know how to find the distance between two ordered pairs. We want to interpret the implied slope of a line using units. We want to graph parallel and perpendicular lines. And we want to determine if two lines are parallel, perpendicular, or neither. The vocabulary of this lesson will be slope, rate of change, linearly, ordered pair, distance, parallel, perpendicular, implied, right triangle, Pythagorean theorem, fraction in simplest form, and irrational number. A slope is a measure of a line's rate of change. Slope is defined as the ratio of the rise to the run. The formula for slope is if x1, y1 is an ordered pair and x2, y2 is an ordered pair on a line, then the slope of the line is defined as y2 minus y1 divided by x2 minus x1. We use the letter m for the slope. Example 1. Calculating a slope from two ordered pairs. Let's calculate the slope of the line that passes through the given ordered pairs. Point M goes through 2, 5. Point N goes through 3, 7. We're going to use the formula. We're going to use M as x1, y1. We're going to use n as x2, y2. This becomes 7 minus 5 over 3 minus 2, which becomes 2 over 1. The rise is 2, the run is 1. B. Point W is at negative 3, 2. P is at 5, negative 6. We're going to use W as x1, y1 and P as x2, y2. This gives us a ratio of negative 6 minus 2 over 5 minus negative 3. This becomes negative 8 over 8, which in simplest form is negative 1 over 1. The rise is negative 1, the run is 1. Positive and negative slopes. Positive sloped lines increase always from left to right. Negative sloped lines always decrease from left to right. Zero and undefined slopes. Slopes of 0 are always horizontal. This means there is no rise in them. Slopes that are undefined are always negative. I said negative, I apologize. I'm going to have to fix that. Slopes that are undefined are always vertical, not negative. So I'll fix that, but I'll keep the video. This means there is no run in them. When calculating a slope that is positive or negative, you can always get a right triangle. Find the slope of the line and find the distance between the ordered pairs on the line. First, let's graph two ordered pairs. Here's the rise. Here's the run. There's the right angle, and there's the line. Now we can clearly see the right triangle. The rise is 12. The run is 10. By definition, slope is rise to run. So we take slope equals 12 divided by 10, and we get a slope of 1.2. Here's point M. Here's point N. What is the distance from M to N? All right triangles obey the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. So what we're going to do is we're going to let the rise equal a, we're going to let the run equal b, and we're going to let mn equal c. Using the substitution property, we now have rise squared plus run squared equals mn squared. Substituting again for the values, 12 squared plus 10 squared is mn squared. 144 plus 100 is mn squared. This means that mn squared must be 244. The square of mn is not the distance that I'm looking for. I'm looking for just mn. So I use the square root property on both sides. The square root of 244 is the distance from m to n. This is called the exact. Plugging into a calculator and taking to the nearest tenth, I get 15.6. This is approximately the distance from m to n. Find the slope of the line, example 2b. Here are 2 points. There's the rise. There's the run. There's the right angle that's been formed. And there's the line. So now we can see the right triangle. The rise is 6. The run is negative 15. Remember, slope is a rate of change. It's defined as the rise divided by the run. So 6 divided by negative 15 becomes negative 2/5, which becomes negative 0.4. So this is a slope of negative 0.4. Here's point W, here's point P. What is the distance from W to P? All right triangles obey the Pythagorean theorem. This is a fact. So a squared plus b squared equals c squared. Let rise equal a, run equal b, and WP will equal c. So rise squared plus run squared is WP squared. Using the substitution property, 6 squared plus negative 15 squared is WP squared. 36 plus 225 is WP squared. 261 is WP squared. But I want to know what WP is, so I have to use the square root property on both sides. The square root of 261 is WP. That's called the exact. Plugging that into my calculator, rounding to the nearest tenth, I get 15.2 is approximately the length of WP. When you have a zero or undefined slope, there is no right triangle that can be drawn. So what is the distance from x to y and the distance from b to c? No right triangles are possible, so these are called straight line distances. So we're just going to count them out. I count the distance from x to y vertically straight down, and I get 11. I count the distance from b to c across horizontally, and I get 13. Remember, whenever you calculate distance, you need to know the following. Distances are never negative. When you encounter a word problem, sometimes a slope is not given directly, but is implied. It's important to know how to find the slope and understand its units. Find the slope implied in the problem and interpret it in a contextual sentence using units. Alan drives from Bangor to Portland, Maine in 2 hours and 35 minutes. The distance between the two cities is 128.8 miles. Now notice, this isn't a question, this is a statement. But there's a slope that's being implied here. The implication here is, how fast did Alan travel on average, or what was Alan's average speed to Portland? A slope is a rate of change, so miles per hour are the units. 2 hours and 35 minutes, written as a decimal, is 2.5833 hours. Remember, we have 35 minutes. There are 60 minutes in an hour. So to get the 2.5833, we take the 2 hours plus the ratio of 35 to 60. And that's how we can convert from a mixed hour-minute into just a pure hour number. Now we take the ratio, 128.8 miles divided by 2.5833 hours. This is approximately 49.9 miles per hour. we have to finish with a contextual sentence. Alan's average speed was 49.9 miles per hour. Sarah's truck cost her $45,000 when she bought it brand new. She knows that automobiles depreciate linearly with time. That means that the relationship of their cost is going down in a straight line fashion. She looked up the Blue Book value and noticed that after 5 years, her truck is now only worth $18,500. The implication here is, what is the rate of depreciation of Sarah's truck? A slope is a rate of change, so dollars per year are the units. The truck has a difference in cost, $18,500 minus $45,000. This is negative $26,500 over a 5-year period. Taking negative $26,500 and dividing by 5 years, we get that the truck has been depreciating linearly negative $5,300 per year. Time for a sentence. Sarah's truck depreciated at an average rate of negative $5,300 per year. Parallel and perpendicular lines. Two lines are parallel if they have the same slope. Two lines are perpendicular if the product of their slopes is negative 1. Graph each pair of lines. Use the slopes of the lines to determine if the lines are parallel, perpendicular, or neither. We want to take lines HJ and KM. So we take the ordered pairs for H and J, K and M, and we calculate the slope of line HJ. 4 minus 3 over 5 minus 2 is 1/3. The slope of KM, negative 3 minus negative 4 over 2 minus negative 1 is 1/3. The slopes are the same, so the lines are parallel. Let's do the same thing, except this time we've switched an ordered pair here. Let's do the slope of HJ. 4 minus 3 over 5 minus 2 is 1/3. Now time for the slope of KM. Negative 3 minus 0 over 2 minus 1. This is negative 3. They're not the same number, so therefore the lines can't be parallel. If I multiply the two numbers, and that's what I mean by product, so if I take 1/3 times negative 3, I get negative 1. So since the product of these slopes is negative 1, that means the lines are perpendicular. Some slopes come in decimal form, and for graphing purposes, it's useful to know how to convert them into a simple fraction so we can determine the rise and the run. Convert each slope into a fraction of simplest form. Keep the units. 5.6 kilometers per hour. Move the decimal to the right once and divide by 10. This becomes 56 over 10, which is reducible to 28 over 5 kilometers per hour. Negative $4.75 per day. Move the decimal to the right twice and divide by 100. This gives me negative $4.75 over 100, and that becomes negative 19/4 dollars per day. Pi inches per second. Well, in this case, unfortunately, not all numbers can be turned into a fraction. Pi is one of those numbers because it's irrational. God bless you wherever you are today.